This is question 6 from exercise 3.3 in Project Maths 3A. We have to find the points of intersection of the given line and the given circle. So we've been given the line x plus 5y plus 13 is equal to 0 and the circle x squared plus y squared equals 13. So in order to start this off, we're going to rearrange our equation of the line so that either x or y is on its own to one side of the equals and everything else on the other. So when we rearrange that, we're going to get x is equal to minus 5y minus 13. And now we're going to take this value for x here and sub it into our circle in place of x. So instead of x squared, we're going to have what we found the value of x to be, which is minus 5y minus 13 all squared. And then that's still going to have plus y squared, and that's still going to be equal to 13. If we multiply this out, there's two ways we can go about expanding this bracket. We could either put them side by side like this, and then multiply it out as you would expanding brackets normally. So you go minus 5y by minus 5y is 25y squared, and minus 5y by minus 13 is plus 65y, minus 13 by minus 5y is plus 65y, and minus 13 by minus 13 is plus 169. And then we add them all up, and we get 25y squared plus 130y plus 169, like that. But the other way that we can expand brackets like that is by following the formula a plus b all squared is equal to a squared plus 2ab plus b squared, which we can see is what would have happened if we followed it up above. A being minus 5y, so minus 5y squared is 25y squared, and then 2ab would be 2 times a times b, so 2 times minus 5y times minus 13 would have given us plus 130y, and then plus b squared would have been plus minus 13 squared, and minus 13 squared is 169, which is what we got in the end. So either way is absolutely fine, although if you remember the formula, it'll make things go a little bit quicker at times. So we put in our expanded brackets over here anyway. So we've got 25y squared plus 130y plus 169 plus y squared is equal to 13. So we're going to add the y squareds and bring the 13 over. So we're going to get 26y squared plus 130y plus 169 minus 13 is equal to 0. And we can tidy that up a little bit further. 26y squared plus 130y plus, and I'm just going to take 13 from 169 and we get 156. That's equal to 0. Now we're going to have to factorize this from here, but that is a thoroughly inconvenient set of numbers to try and factorize. But each one of them is actually divisible by 26. So 26y squared divided by 26 is just going to be y squared. And then 130 divided by 26 is going to be 5, so we have 5y. And then 156 divided by 6 is going to be, or divided by 26 is going to be 6. We get equal to 0 like that. And now we've got a much easier quadratic to factorize. So when we factorize this out, we're going to get y and y. And then we need factors of 6, that's sum to 5, so we need plus 2, plus 3, which means that from here we've got y equals minus 2 and y equals minus 3. So those are our two values for y, but we've got to use them to get values for x. So we're going to go back up to our line equation over here, and we're going to first do that out when y equals minus 2, in which case x is going to be equal to minus 5 times minus 2 minus 13, which is going to be 10 minus 13, which is equal to minus 3. which gives us the point -3, -2. And then we're going to do this again when we've got the point, and when y is equal to -3. So y equals -3, which means we're going to have x equals -5 times -3 minus 13, which is going to be 15 minus 13, that's equal to 2. So we get the point 2 minus 3, like that. And those are our 2 points of intersection between the given line and the given circle. And that's that.